All right, so for this first problem, we're just going to talk through this one first before you have to do any of them on your own. First, notice what makes this one different is that we don't have any equations set up this time where we know what x equals, y equals, or z equals. We can't find one of those out really fast. And we also don't start with two equations with two variables. Now, if we had that, we could do it, right? You know that if we have two equations with two variables, we can solve it. Well, we basically can make that our target then. Because I already have this equation with two variables. I just need to figure out how to combine these other two to make them only have the same two variables. And so what we're going to do is, since the first equation has only y and z in it, we're going to create another equation that has only y and z. In other words, I'm going to cancel the x's out from these last two equations. Notice it's set up for us to do that. So if I just add them straight down, then this is what I get. I just have y minus 3z equals negative 3. Notice then, I had y and z here, I have y and z here. That means I have two equations, each with the same two variables. And once we get there, then it's a matter of solving it the same way that we've been doing with all of them, right? This is familiar from this point. So I went ahead and just chose to multiply the second one by negative 1. Then we can go ahead and add them, because I chose to make the y's eliminate. I get what z is. I take what z is, plug it back into one of these equations. I want to plug it back into one of them that has just the y and the z in it. So then I can solve for y. Then once I know what y equals, then I can take the y and the z that I found and plug them into either of these equations. Now notice, I'm still trying to figure out what x is, so plugging it into the first one obviously wouldn't help, right? I got to plug it into one of them that has x in it. Doesn't matter which one of those two. You do that work through, you end up finding that x equals 1, and you're done. So notice what our strategy was. Since I knew that I had just y and z in this equation, I made these two also become just y and z. We're going to apply that same strategy to this system. This one you do need to write out, please. And so in this one, you notice the key thing that's really helpful to note is this middle equation. It only has x and y in it. So since that one just has x and y in it, I want to create a second equation that also just has x and y. So that means I'm going to take that first equation and this third equation, in other words, the other two, and I'm going to make them have x and y, which means making the z's cancel out. So if I want the z's to cancel out, they aren't going to do that right now, will they? So what do I need to do in order to make them cancel out?
Times 7.
Yep, exactly. Multiply that first equation by 7. And then we're going to write both of those equations together after I do that. So this is what you should be looking at. And remember why we did that. We multiplied that top one by 7 because we want the z's to cancel out. Well, now they will when we add them up together. So go ahead and add those two equations together and see what that gives us. When you do that addition, you should get negative 62x minus 26y equals 160. All right, now remember why we did that. I wanted a second equation that had both x and y in it, because I already had one equation with x and y in it. So now that I have this equation here, I want to put it together with the other one. And so I now make my new system of two equations with two variables using those two equations. And I do that because now this is something I can solve. Now I know you're going to look at this probably and be like, yeah, but it looks a little messed up. Because, I mean, these are some much bigger numbers than what we would typically create for an elimination method problem. But we still can use the same method. It's just the numbers are a little bigger. So, go ahead and do that work, please. Go ahead and solve this system using elimination. Once you get to this point, you notice the process from here is exactly the same as what we've been doing. So the only new stuff that we did today on this problem was just seeing how to get to this equation right here. Everything else is the same as you've been doing. Everything else is the same as you know. Finish from there. Having done those, we're now going to go and tackle this problem. Now, again, I'm going to make this like we did with the first one. You do not have to write this one down. I'm just going to talk you through the method and the strategies of how we do it, and then we'll do one like it together. And so you can have that one written down. All right, so notice what makes this one different from the previous ones. This type, you notice 3 variables, 3 variables, 3 variables. None of our equations are set up in any way that's going to make our lives a lot easier. And so we need to kind of figure out how will I do it. And my basic strategy is that I want to be able to take 2 different combinations of equations and turn each of those into equations with only 2 variables in them. And I'll show you what I mean here in a moment. First of all, a hint moving forward. Whenever you're writing these problems down on your paper, one of the things you can do to make your life a whole lot easier is to write it all evenly spaced. I normally don't use this font for our problems because it could get really boring to look at this way. But what this font does do is it lines up all the x's above each other, all the y's above each other, and all the z's above each other. And it makes it a little bit easier to tell which of those 3 variables is set up beautifully to eliminate each other. Well, if I look at the x's, I mean I can use this with both of those, but this combination certainly isn't too pretty. The y's, well, notice 5 and negative 5, 5 and negative 5. That one's set up beautifully. So the y's are actually set up wonderfully for us to be able to eliminate some stuff. Now, you might also be wondering, what about the z's? Well, yeah, the 7 and the negative 7, they're great. Although if I have to then combine the 7 and the 4, that's not going to be so great. And so I definitely want to use one where I can combine all 3, at least at some point along the way. Now, that's exactly what I'm going to do. I'm going to start by picking 2 of the equations to add. And in this case, I'm choosing the first and the third. Now, I know I want the third to be involved because the third one is the one that has the negative 5. From there, it was an arbitrary choice to make it 1 and 3 or 2 and 3, because those are the 2 that are both positive 5s. But I went ahead and grabbed the first and third equations and turned those into a system. And remember how before we created that system because we wanted one of the variables to go away, get eliminated when we added them? That's why we have this. So I want those y's to eliminate. So I now add them. When I do that, notice 8x plus x is 8x. 5y plus a negative 5y is 0. That's what I was going for. But you notice something else happened to occur at the same time. That 7z plus negative 7z also added to 0. It also eliminated the z's. And then we get equals negative 40. Now, the fact that the z eliminated as well as the y is uncommon. But it does happen. And when it does happen, it makes our lives a lot easier. Because you'll notice, now I can know what x is. And I can just know that value right away, right? I can now know x equals a negative 5. The thing, though, is none of these equations are just in terms of like x and y. They all still have y and z in them. And so I still need to create another equation that just has 2 variables in it. Just it's going to be x and something else. So remember, I was trying to eliminate the y's before. I'm going to do the same thing. I'm still going to try to eliminate the y's. But I must choose a different pair of equations. If you just said, well, I'm going to choose the same 2 equations, but maybe you did it slightly differently. If you use the same 2 equations, you're actually just going to start running in mathematical circles. You'll end up with equations that say things like 0 equals 0, which is true, but not at all helpful. We didn't need to solve an equation to know that 0 equals 0. So in this case then, I'm still wanting y's to eliminate. This is my only -5, so I'm going to do 2 and 3. Equations 2 and 3 here. And so I grabbed equations 2 and 3, wrote them as their own system. Yes, we want to keep the bracket with it. And then go ahead and add them straight down. And when we do that, notice I ended up with an equation that has both x and z in it. This is what I expected to happen the first time, but it didn't. But that's okay. I like the result that we got. In this case, I ended up with this. But notice I can now use this equation combined with what I found the first time. X equals -5. So I can take what x equals here, that -5, and I can plug it in for x here to figure out what z is. So the rest of this then just becomes fairly straightforward. So I plug the x in, solve for z. We know that z is 4. And now that I know what 2 of the variables are, I can plug that into any of these 3 to solve for y. And again, it doesn't matter which one you plug into. Go with one that looks easiest, or just arbitrarily choose one, as you wish. And so I plug in the x and z. I chose the first equation. And we can then find that y equals -1. And we're done with that one. And so notice our process. Basically, we started by looking to see what is the easiest variable to cancel out twice. And then I actually did that. I canceled it out 2 different times and worked with what I got from those 2 different times. We're going to now do that with this system of equations. So go ahead and write this one down on your paper. So the first thing we do when we look at one of these is really plan a strategy. Think about which variable is it going to be easiest to eliminate twice. And as I look at it here, the z's jump out to me because I see 10s in all of those z's. So they're definitely going to probably be the easiest ones to eliminate. So basically my plan going forward then is that I'm going to try to make the z's get eliminated 2 different times. So I'm going to go ahead and choose the first and second equations first. Because you'll notice the -10 and the +10, they're going to eliminate each other. So write out that combo, and then go ahead and do that addition. Go ahead and add those 2 equations together to see what that gives you. When we add those, you should get -5x plus 7y equals -22. Now, keep that equation just kind of handy there because we can't use it yet. But we will be able to use it here pretty soon. Because I now need to make another equation that contains just x and y. In other words, I need to eliminate z again. Now, as I'm looking at all the different combinations, I just used 1 and 2. What's going to be the other really easy combination? Yep, 1 and 3. Because again, the -10 with the +10 is what I want to use. And so, start by writing down what that little 2 equation system would look like. And then add them to make the z's eliminate and see what that gives you. And so when we do that addition, let's make sure you got the right thing this time as well. You should get -6x plus 10y equals a -28. Now, at this point, there is a decent chance that you might be sitting there going, so what? What did that get us? Well, what that did, by doing that both times, is we now have 2 separate equations that both involve the same 2 variables. And if we have 2 equations with 2 variables, I can set that up as its own little system and solve that resulting system of equations. And so you'll notice that in order to solve this, you're going to have to multiply one or both of these equations by something. Actually, in this case, both. If you weren't sure what you wanted to multiply by, I went ahead and multiplied the first one by 6, and I multiplied the second one by -5. you go with that. Your work would match mine then. But of course, that's not the only way you could have done it. There were lots of different ways that you could have gone about doing it. But then solve it from there. Right, and so when we do that work, we go through, and my work happened to give me y first. So I found that y was -1. Once you find one variable, the question then comes up, what do I plug it into? Because you can't plug it into one of these original equations at this point. It's not going to help you. But you can plug it into any equation that we have along the way that has both the y in it, which is the one that we have, and another variable. So like the x's. So I could plug it into this equation. Or I could plug it into this equation. Heck, I could plug it into these too, but why would I want to work with the bigger numbers? And so, like I chose, as you can see over here, to plug it into the first equation. So I plugged in the y of -1, and then just solved it through to figure out what x was. We find that x is 3. Now that I know x and y, I can worry about z. Which means now I go back to one of the original equations that has x, y, and z in it. And for me, I chose to just plug it into the first one, just arbitrarily. And so I plugged in my x and y values, then solved that. And you should find that z equals 1.